Start ಮಾಡ್ತೀನಿ. Good evening, everyone. Myself Altaf and this are my teammates Sharath, Shriyari and Akash. Today we are here going to represent about our project, which is overfitting and underfitting analysis. Next slide. Introduction. In machine learning, the main goal is to build machine learning model, which is able to learn patterns from a data, which is from external sources and make accurate prediction on a new or unseen data or a raw data. In machine learning, the main problem is underfitting, which happens when a model is too simple to capture the underlying structures of the data. It can be performed poorly on both training and test data set because
Papa,
it
specs
usually
కూడా
fails to it usually fails to learn important relationships. The main challenge in the machine learning models is to find the right balance between learning too little or learning too much is a major challenge. Next, my friend Sharath will continue.
Thank you, Altaf. Here coming to the objectives. In our main project, the main goal is to exploring the underfitting and overfitting, especially using the polynomial regression techniques. And we will comparing the models with the polynomial degrees, try to identify the optimal model by evaluating the bias variance and trade-off. And we also demonstrate that the how the regularization helps to the deal with the overfitting. And next slide, data description. Here in the data with the house prices data set we are using with the Kaggle's advanced regression computation. It includes a total 1460 samples, out of which we will splitting like 70% for training and 1022 image samples images that are which they containing remaining 30%, and which is 438 samples for validation. And next slide, my friend Akash will continue.
ಲೇ ಪಾಸ್ ಮಾಡೋ ನಾನಲ್ಲ ಶರತ್. This slide will be containing the model design. That this model is based on the polynomial regression, which will help to capture non-linear relationship between the input and the target variables. For the experiment, I tested polynomial degrees of 2, 5, and 10 to analyze how the model complexity affects performance. The next will be the input features used is graveyard area, which represent the above grounded living area of houses. This model is implemented using a Python along with the scikit learning library for regression modeling and Matplotlib for visualization. Data valid me to clear studies how polynomial degree calculation under fitting and overfitting. The next slide will be underfitting and overfitting analysis. Now let's discuss the comparison between the underfitting and overfitting observed in the models. For the degree 2 model, there will be a high error on the both the training and validation set, which indicates that the model is too simple to capture the underlying data patterns. Hence, we can conclude that model underfits the data. On the other end, the degree 10 model achieved a very low training error but the high validation error. This will show the modeling is memorizing the training data and facing to generalize well to unseen data, a clear case of overfitting. So this helps to understand that model complexity needs to be balanced to achieve the best generation performance. The next slide will be presented by my friend Sridhari.
Thank you, Akash. Result and analysis. Result and analysis. Degree 2. The model is too simple and fails
Very
to
unmute your mic.
capture. Thank you, Akash. Result and analysis. In degree 2, the model is too simple and fails to capture the underlying pattern in the training data. This leads to high error on both training and validation sets, and it is a more complex model. Example like increased polynomial degree. In degree 5, the model is too complex and learns the noise and random fluctuation in the training data to well leads to very slow training error, but it is a high validation error. And it is a use of complex model like decrease polynomial degree or apply regularization. And degree 10, This model achieves the good balance. It is the complex enough to fit the data well, but it's simple through not over memorize the noise errors are low and similar on both sets, and it is the ideal model performance. Next slide. Conclusion and future scope. In degree 2 underfit too simple, it is a model is a too simple, it exhibits high errors on both training and validation sets. In degree 10, it is a overfits, it is a complex. In the model too complex, it achieves very low training error but a high validation error. The model essentially memorized the training data including noise, making it problem poorly on unseen data. And degree 5 degree 5 best, it is a best balance and it is a good bias variance trade-off, and the model offer the best bias variance trade-off. The training data validation errors are both low and closely balanced, making it most reliable model of generation. Future scope. Future scope is future scope, it applying the regularization with hyperparameter tuning to reduce overfitting in a complex model, and it is using the validation to better users model true performance and stability, and incorporate more input features like multivariate regression to potential improve the model predicting the power. Thank you.